Hello viewers, in today's lecture we are going to solve some problems related to partial fractions. So let us take this first problem. Here the integrand is 5x divided by x plus 1 and x square minus 4. Now see, this function can be written as 5x divided by x plus 1, and this can be factorized into two linear factors. So this is x minus 2, x plus 2. Clear? Now here we have three linear factors in the denominator. So using partial fractions we can write this function as a divided by x plus 1, then we have b divided by x minus 2, and then we have c divided by x plus 2. Clear? Now our aim is to find the value of these constants. Clear? Okay, so what we will do, we will take the LCM of these three expressions. So we have x plus 1, here we have x minus 2, here we have x plus 2, and in the numerator we have x minus 2, x plus 2 a times, plus b times we have x plus 1, and then we have x plus 2, and then we have c times x plus 1 and x minus 2. Clear? Now this is 5x divided by x plus 1 and x minus 2 and x plus 2. Clear? Now if we compare both these sides, see, here we have x plus 1, x minus 2, x plus 2. Here also we have x plus 1, x minus 2, x plus 2. So therefore equating these two expressions, we have 5x is equal to a times x minus 2, x plus 2, then we have b times x plus 1, x plus 2, and then we have c times x plus 1, x minus 2. Clear? Now from here we will find the values of a, b and c. Clear? So here we will take the method which we generally use. If we since this expression can be taken as an identity, so this is valid for all values of x, the real values of x here. So if we take x equal to 2, then we see that this term becomes 0 and this term becomes 0. So we have 5 2s are 10, because here we'll substitute x equal to 2, so we have 10, and then we have this term is 0, this term is 0 because x equal to 2, so we have b times this is 2 plus 1, this is 2 plus 2, so we have 3, and this is 4, so this is 12b, right? 12b, so this is b is equal to 10 over 12, so this is 5 over 6. Now if we put x equal to say minus 2, then see this expression becomes 0 and this expression also becomes 0, so we have minus 10. Now x is minus 2, so we have minus 10, and here we have c minus 2 plus 1, then we have minus 2 minus 2, so we have this is c times minus 1 times minus 4, so this is 4c, and c is minus 10 by 4, that is minus 5 by 2. Clear? Okay, now if we put x is equal to say minus 1, then we see that this term becomes 0, this term becomes 0, and we are left with this term. So here we have minus 5, because here we put x equal to minus 1. So we have minus 5, then we have a, we have minus 1 minus 2, minus 1 plus 2. So this is minus 5 is equal to a times minus 3, and then we have we have plus 1, and we have minus 3a. Clear? So this is equal to this implies a is equal to minus and minus get cancelled, so we have 5 by 3, right? So once we find the values of the constants here a, b and c, the process of integration becomes quite easy, right? Therefore now I can be written as this is integral. We have this expression is equal to a over x plus 1, then we have b over x minus 2, and then we have c over x plus 2, right? Now we'll substitute the value of a, b and c here. So we have 5 by 3 divided by x plus 1, and then we have the value of b as 5 over 6 divided by x minus 2, and then we have minus 5 by 2 divided by x plus 2 and dx, right? Now this can be written as if we separate all these terms, we have 5 by 3, then we have 1 over x plus 1 dx, then we have 5 by 6 integral 1 over x minus 2 dx, plus here we have minus 5 by 2, so we have minus 5 by 2, and integral 1 over x plus 2 dx, right? Now viewers, always remember that the integral of 1 over x plus a or minus a is log of x plus minus a. Clear? So we will make use of this result here. So we have 5 by 3, and we have log of x plus 1 plus 5 by 6, and log of x minus 2, and then we have minus 5 by 2 log of x plus 2. Clear? And there is a constant of integration, right? So this is our final answer. Clear? Now viewers, let us take this problem. Here we have to integrate this function. Now we have to decompose this rational function into partial fractions. So what we will do, see here we have the linear factors x plus 1 and x plus 3. Now x plus 1 is repeating twice. Clear? Suppose if we do not have this square, then the partial fractions would be a over x plus 1 plus b over x plus 3. But see, if we have here we have x plus 1 square, so therefore there will be one more term in this partial fractions. So what we will have here, so we'll have a over x plus 1, then we will have b over x plus 1 square, and then we will have c over x plus 3, right? So I hope you must have got this point. Here we have the linear factor, repeated linear factor. Here we have square, so the partial fractions would be a over x plus 1, b over x plus 1 square plus c over x plus 3, right? Now let us take one more case. Suppose if we have here also a square term, right? Suppose we have x plus 3 square, then what will be the partial fractions? Then we'll have c over x plus 3, and then we'll have one more term here, d over x plus 3 square, right? Okay, so but in our present question we have this rational function, so the partial fractions would be this. Clear? Now we take the LCM. Here we have x plus 1 square and x plus 3, and now we have x plus 1 divided by x plus 1 square, x plus 3 is divided by x plus 1, so here we have x plus 1, x plus 3, right? Then we have plus b, then we have x plus 1 square and x plus 1 square get cancelled, so we have b times x plus 3, and then here we have c, x plus 3 and x plus 3 get cancelled, so we have c times of x plus 1 square. Clear? Okay, now since this rational function is now equal to this rational function, so we have 3x minus 2 is equal to this term. This term will be equal to this term, right? So we have a times x plus 1, x plus 3, and then we have b times x plus 3, and then we have c times x plus 1 square. Now again, this is an identity, and we have to find the values of a, b and c. So what we will do, we'll put x equal to if we take x equal to minus 1, then see this term becomes 0 and this term becomes 0, so we have 3 times of minus 1 minus 2 is equal to b times minus 1 plus 3, right? So here we have taken x equal to minus 1, which makes this term 0 and this term 0, so we have this expression. So here we have minus 3 minus 2, and this is b times 2, so this is minus 5, 2b, so therefore b is minus 5 by 2, right? Now we put x equal to minus 3, so this term and this term get cancelled, or they get 0, equal to 0, so we have 3 times minus 3 minus 2, and we have c times of minus 3 plus 1 square. So this is minus 9 minus 2, this is c times minus 2 square, so we have minus 11, this is 4c, so therefore c is equal to minus 11 by 4. Now if we put x equal to say x equal to we can take 0, right? Then what we will have? We will have an equation in a, b and c. Now here we have taken x equal to 0 because x equal to 0 is the simplest value here. So if we substitute here, we get 3 times 0 minus 2 is equal to a times, this is 0 plus 1 1, 0 plus 3 3, so 3 ones are 3, so we have 3a, and here we have 3b, and here we have c, 0 plus 1 1, 1 square is 1, so we have plus c, so therefore we have 3a plus 3b plus c is equal to minus 2, right? Now our aim is to find the value of a. So we'll substitute these values b and c in this equation. Now substituting these values here, we have 3a plus 3 times of minus 5 by 2, and then we have plus c, and c is minus 11 by 4 equal to minus 2. So this is 3a minus 15 by 2 minus 11 by 4 is equal to minus 2, and we have 3a equal to minus 2 plus 15 by 2 plus 11 by 4. Now we'll solve this expression. So we have 4 here, and then we have it is 8 plus 30 plus 11. So this is 3a is equal to this is 22 plus 11, 33 by 4. So this gives a is equal to 11 by 4, right? Now viewers, once we have obtained the values of a, b and c, we can easily calculate this indefinite integral. So therefore I becomes integral of this expression is equal to this expression. So we have a, the value of a is 11 by 4 divided by x plus 1. Then we have b is minus 5 by 2 divided by x plus 1 square, and then we have the value of c as minus 11 by 4 x plus 3, and here we have dx. Now we separate these three terms. So we have 11 by 4, then we have dx over x plus 1, then we have minus 5 by 2 and integral of dx over x plus 1 square, and then we have minus 11 by 4 and integral of 1 over x plus 3, right? Now the integral of 1 over x plus 1 is log of x plus 1. Then we have minus 5 by 2. We know that the integral of, always remember, integral of 1 over x plus 1 square is minus 1 over x plus 1, or in other words we can say that 1 over x plus a square is equal to minus 1 upon x plus a, right? So either we take x plus a or we can take x minus a. So if here we have x minus a, then here we have minus 1 over x minus a. So here we have minus 1 over x plus 1, and here we have minus 11 by 4, and this is 1 over x plus 3. So this is log of x plus 3, and this is the constant of integration. So viewers, now we can write, we can simplify it. We have 11 by 4 log x plus 1, and then we have minus minus plus, so we have 5 by 2, and this is x plus 1, and minus 11 by 4 log of x plus 3, and here we have the constant of integration, right? Now if we combine these two terms, then we can write a more simplified form of the answer, and here we can have 11 by 4, and we have log of x plus 1, and here we have minus log of x plus 3, and then we have plus 5 by 2 x plus 1 plus c, right? Now this is log m minus log n, and log m minus log n is equal to log m upon n. So therefore we have 11 by 4 and this is log of x plus 1 divided by x plus 3 plus 5 by 2 times x plus 1 plus c. So this is the final result of the given integral. Now viewers, let us take this problem. Here we have to integrate x over x square plus 1 and x square plus 2. Now see, here we will apply actually two methods. The first one is the substitution method, and the second one is the partial fraction method. So first we will make use of substitution, and first we substitute x square is equal to y. Now this is 2x dx is equal to dy, so x dx is equal to dy over 2. Now we substitute this value of x dx here, so therefore I is dy over 2 divided by we have y plus 1 and y plus 2, right? So this can be written as half. Taking half outside the integral, we have dy divided by y plus 1 and y plus 2. Now see, this integral will use the partial fraction method. 1 over y plus 1 and y plus 2 can be decomposed into two partial fractions as a over y plus 1 and b over y plus 2. Clear? Now we can write it as a times y plus 2, then b times y plus 1, and we have here y plus 1 and y plus 2. So 1 over y plus 1 and y plus 2. Now if we compare both these rational functions, we see that 1 is equal to this 1 is equal to this expression, that is a times y plus 2, and then we have b times y plus 1. Clear? Okay, now our aim is to find a and b, and from here if we put y is equal to minus 2, then this term will become 0, so therefore we have 1 is equal to b times minus 2 plus 1, which is equal to minus b, so therefore b is equal to minus 1. And if we put y is equal to minus 1, then this term will become 0, so therefore we have 1 is equal to a times minus 1 plus 2, so we have 1 is equal to a, so therefore the value of a is 1. Clear? So therefore here we have to integrate this function. So now we can integrate it because we have to find the value of I. So I is half. Here we have half, then we have a dy here, and y plus 1, y plus 2. So what we will do here, so we have half and we have integral of this term, right? We have the integral of this term. So this is half, and we have integral, the value of a is 1 over y plus 1, and the value of b is minus 1, so we have minus 1 over y plus 2 dx, right? Now this expression can be evaluated as half. We have integral of here we have y, so we have dy over y plus 1, and then we have minus dy over y plus 2, right? So viewers, here we have half, this is the log of y plus 1, this is log of y plus 2, and we have plus c. So here we have half log mod of y plus 1 divided by y plus 2 plus c. Clear? And here we have used the property of log, that is log m minus log n is log m upon n. So again we'll resubstitute the value. So y is equal to x square. So our answer is x square is equal to, here we have substituted x square is equal to y, so substituting it here, so we get half log we have x square plus 1 divided by x square plus 2, and the constant of integration is c. Clear? Now viewers, let us take this problem. Here we have to integrate 2x minus 3 divided by x square plus 1 x minus 2. Now here we see that this is a linear factor and this is a quadratic factor, and this factor cannot be factorized into linear factor, right? Linear factor. So we cannot decompose this factor into linear factors, right? Now this is a linear factor. So what we will do, if we wish to find the partial fractions, so the partial fractions would be ax plus b, ax plus b divided by x square plus 1, right? So we always write ax plus b in the numerator whenever we have a quadratic function or quadratic factor which cannot be decomposed into linear factors, right? So I have already explained all these things in my previous video, so you can watch it. And now we have this factor, so we have here c divided by x minus 2, right? So whenever we have a quadratic factor which is not factorizable into linear factors, so we always write ax plus b. We cannot simply write say a divided by x square plus 1. So we cannot write it. So we have to write ax plus b. Clear? Okay. Now we'll take the LCM, and we have here x square plus 1, and then we have x minus 2. Now we have ax plus b times x minus 2, and then we have c times x square plus 1. Now if we compare this one with this one, then we see that 2x minus 3, that is 2x minus 3 is equal to ax plus b times x minus 2 plus c times x square plus 1, right? Now our aim is to find a, b and c. Clear? So what we will do, we will again take this expression as an identity, and we'll substitute, first we will substitute x is equal to 2. So this term will become 0, and we have 2 times 2 minus 3, this becomes 0, and here we have c times 2 square plus 1. So this is 4 minus 3, and we have here 5. 2 square 4 plus 1 5. So 4 minus 3 is 1. So therefore C is 1 over 5. So here we will write 1 over 5. Clear? Okay. Now we will find the value of A and B. Now for A and B, we can take or we can compare the coefficients on both the sides. So if we multiply these two expressions, we get ax square minus 2ax plus bx minus 2b, right? And here we have cx square plus c. Clear? Now if we compare the coefficient of x square, so we have a plus c times x square, and then we have minus 2a plus b is times x, and then we have c minus 2b. Clear? Now if we compare both the sides, then we see that here we do not have the coefficient of or we do not have the quadratic term. See, here we have 0x square. So if we compare the coefficients, we get a plus c is 0. Now c is 1 by 5, so we have a is equal to minus c, and c is 1 by 5, so we have minus 1 by 5. So the value of a is minus 1 by 5. Now if we compare the coefficient of x on both sides, see, here we have 2, and here we have this term minus 2a plus b. Now we have 2 minus 2, the value of a is minus 1 by 5 plus b. Now b can be written as 2 minus 2 by 5, minus minus plus, and then we take 2 by 5 to this side. So we have 5 to the 10, 10 minus 2, 8 by 5. So here we have 8 by 5. Now after finding out these values, what we will do, we will integrate this integral, and now we have this integral. So this function is equal to this, so we can write integral, and then we have ax plus b divided by x square plus 1 plus c divided by x minus 2, and here we have dx. Now we will substitute the value of a, b and c here. So what we will get, we have minus, here we have minus 1 by 5x and plus 8 by 5 divided by x square plus 1, and then we have the value of c as 1 by 5 and x minus 2, and here we have dx, right? Now if we break or if we write the individual integrals, we have minus 1 by 5, then we have x divided by x square plus 1 dx, then we have 8 by 5 integral of 1 over x square plus 1, and then we have 1 over 5 integral of 1 over x minus 2, right? Now we have three integrals here. To evaluate these integrals, we will make use of standard results. So we see that here if I multiply it by 2 and here we divide it by 2, we see that the derivative of x square plus 1 is 2x. So therefore this is minus 1 by 10, and we have log of x square plus 1, right? Because the derivative of x square plus 1 is 2x. plus this is 8 by 5, and if I write it here square, then it becomes x square plus a square, and the integral of 1 over x square plus 1 is tan inverse x. Clear? And then we have 1 over 5, and the integral of 1 over x minus 2 is log of x minus 2, and we have the constant of integration as plus c, right? So viewers, this is our required answer, but here I would like to mention that if we have f dash x and in the denominator we have a function, then always remember that the integral of this function is the log of f of x, and we know that the integral of 1 over x square plus a square is 1 over a and tan inverse x over a. Clear? This is tan inverse x over a, and we also know that the integral of 1 over x plus a or minus a is equal to log of x plus minus a, right?